Hey guys, welcome back. This is Physics for Life Science. And today we're going to be talking about electric fields and electric field lines. So, to begin with, I'm just going to make this statement right here. So, electric field lines is just how an electric field behaves, and from our previous videos, we know that positive charges tend to push things away from them. So, what you do for their field is you just create lines going away from them and the negative lines coming into it. So keep that in mind because it's going to be helpful in making sense of an answer that we're going to soon come to realize. All right, so moving on to vectors, fields. So as we said earlier, electric fields is a vector, and it's defined as E is equals to the force over Q. So force, it's not going to be our regular MA because we're talking about electric force. So this is actually going to be from our previous video, K Q1 Q2, remember big K little k, over R squared divided by little q. So notice that the little q's cancel and you actually end up having a nice formula which is just K big Q over R2. It's just the same thing as gravitational, just any planet itself has a gravitational pull. It's just the same thing here. We're saying an electric field exists as long as there's a charge that exists. Same thing as a magnetic field exists as long as there is a mass, a planet present, or a black hole, etc. Right? So it's the same idea. So now um, let's do an example. Let's do examples like always. So let's move here, keep that formula in mind. And now let's say there are two charge, actually one charge, because we're only caring about one charge. And one of them is positive, the other one is negative, negative. And now what we do is there is a point P away from it. Alright. So the distance to point P, let's just make point P right here. Alright, now notice point P is going to be a very small, insignificant charge. So let's assume that it's just going to be a voltmeter, just measuring how much electric field there is around there. So you just press there and you'll read the electric field. So you're reading the electric field at point P, all right? And so your charge, either positive or negative, it's going to be 2 microcoulombs, and of course this is negative 2 microcoulombs, right? So now we're going to say calculate the electric field at point P. So electric field at point P. Now how can we do that? Well, using this formula right here. So we're going to say E at point P is equals to K Q over R squared. Now remember from previous videos, this K is simply 9 to the power of 9 newtons times meters squared per coulomb squared. And what is our charge? Well, it happens to be 2 e to the negative 6 coulombs. Now remember for both of them, right? Remember why I'm leaving the negative outside. If you don't remember why, please go back and check in our videos. Now divided by r squared, what's the distance? I forgot to give it to you. It's going to be 0.4 meters or 40 centimeters, right? So we go here, 0.4 meters squared. Now, pause the video, plug in the numbers, and you should get 1.1 e to the 5 newtons per coulomb. All right? So now this is your electric field at point P. Now, is it away or towards the charge? Well, now this graph right here, or this diagram comes into play. Now for this, the positive particle, we said positive is always pushing it away. So this electric field is going to be going away from it. And for this one is going to be going towards it. Right? So that's pretty much it. Alright, so now just some simple things to mention to get out of the way. Reminders. So one big one is there is no electric charge. So no electric charge at point P. Now you may be wondering, oh, why? Well, if you look at our previous video, right, in order for there to be an electric charge, there has to be 2 charges or more. So because it has to have 2 charges or more, right? However, there is an electric field, because electric field is independent of other charges. If there is a charge, there will be an electric field. However, there is not an electric charge. So you got to be careful with the terms because they get confusing. Electric charge depends on 2 charges or more. An electric field is only dependent on the presence of 1. Alright? So now, something really quickly that your professor will probably throw in there. Now, realize that from our equation here, right? Previous one, this one right here. We said E is equals to F over Q, right? So that means that F is equals to the electric field times our charge, which would end up being a force, right? Times coulombs divided by coulombs gives you newtons. But then also remember what we know about force from classical mechanics. Force is equals to ma, right? But it also equals electric field times charge. So from here you can find the acceleration of any particle if you know the electric field, the charge, and the mass of it. So I hope this helps, guys. And good luck with physics. So remember, like us on Facebook, follow us on YouTube, and leave us any comments to see how we can help you guys out.